But what use can be made of it to prove that these projects do not really have to come from space? You really can do real science from simple things. Let me start with Mateusz Kośnik. And Alicja Żelazko.
Tremendously honoured to be here with such a marvellous audience. So, welcome. We would like to show you the results of our work regarding STEM projects, and the title is Mathematics of Soap Bubbles, which we are to explain in more in detail eventually. So the plan of our presentation includes aims of the project, open educational resources that were used regarding the topic, and the implementation of the very project. We wanted to focus upon STEM subjects, so you probably know the abbreviation, which stands for Science, Technology, Engineering and Math. I mean, the first case we want to highlight is the surface area with constant volume of the bodies presented in the picture below. So we have a sphere, we have a cylinder, and we have a cube. And the question is, which body would have the smallest surface area given a constant volume? It's a valid question regarding the soap bubbles in mathematics, which is to be yet determined. But these are prime and transparent examples of what we want to explain further. As for open educational resources, these are just a few examples of what we used during the project. So, well, by saying we, I wanted to be more accurate, because the students were dealing with this part more directly. So we have mural, GeoGebra, art steps, and Edpuzzle, and some other examples. So, regarding the very implementation of the things we are just discussing, the students conducted an experiment with the use of the following elements. So they needed soapy water, they needed rings made from cream or yogurt cups. So they literally cut off the upper parts of those containers. Next, tape measure, ruler, graph paper for taking approximate measurements, on which I'll just develop later on. And background adjustments. So they definitely needed a certain background. They needed certain circumstances to make it more meaningful and logical. As we can see, the results were presented in the form of a link between the two rings, and the very fabric of it was the soapy water that that created a certain shape. And we wanted to show you what results came from it. Namely, we have a catenoid here. Two pictures, one two-dimensional and the second one is in 3D. So based upon the certain values and rates that were included in this project, we wanted to show you that when we have this hyperbolic cosine marked with a purple line, it matches really great with the shape and with the tension of the catenoid that the students received during the experiments. So, in fact, we don't have intersection points presented here because I'm not sure if you can notice that, but between the catenoid and the cosh, there are small spaces on the left and on the right, so there are no intersection points in that example. Now, the calculation of catenoid surface area. We see a formula on the top of the page. The formula was pre-made for the purpose of calculation, so it wasn't provided by the students. They were already operating on this very formula. Of course, with the use of certain parameters or values that are presented here. And the conclusion is as follows. The surface area of a catenoid is smaller than that of a cylinder, which is a very valid information, a very valid piece of information. Why? Because initially, when we had the cylinder, the height was determined as a straight line, and with the use of a catenoid, we have this concave shape, right? So, provided that we would use rotation to visualize the shape of the catenoid itself. So that's how they achieved the results. Minimum surface in everyday life, because minimum surface is what they wanted to determine in the case of catenoid and its creation. And now you have some examples of the application of methods used during the project. It's an art gallery. It was made by the use of which program? It was Art Steps, right? So there are some irregular shapes and figures, but they were created in a mathematical way, so via use of certain formula. Students' output, right? So the shape of water, minimum surface with the use of Art Steps Gallery, GeoGebra, so the catenoids design, and some examples of minimum surfaces regarding natural phenomena. Well, the partnership, as you can see, is transparent. We want to highlight one more thing, namely the participants of the project. There were 45 students involved in it. There were 5 teachers that were included in this project, and that's for the statistics, I guess. And one more thing concerning our online class, because it all has something in common with online lessons. There was a lesson conducted between November and December last year, which was an online lesson. And that's pretty relevant to highlight that the students did not did not participate in those activities in real, but through online means. Some of them mentioned before. I think that's it. I do hope that you find our idea interesting, because nature itself strives to reach minimalism, right? So that's why we wanted to focus on the very topic of surface, of minimum surface, and all the other aspects included in this work. So, in short, thank you for your attention, and that's it.
Myślę, że już nikt.
I believe that the cell bubbles will never be the same if you know that it's hyperbolic cosinus, that is, the connection of two exponential functions, which describes the shape of the concave bubble. It is bad news for those who plan any technical studies. Unfortunately, in order to describe even the simplest thing in true mathematic notions, you really have to plunge in mathematics.